Hi, everybody. This is Deanna Kosaraju, founder of Global Tech Women. Welcome to Voices 2015, where we are now launching into the Asia-Pac time zones. So we are going to be up and about for the next 19 hours. We're going to be talking cool technology. We're going to be talking professional development, and we're going to be talking about issues for women on a regional, national, and international level. So I hope that you're staying tuned with us, and we'll watch these sessions. And if you have to go to sleep, that's okay, because we're recording these sessions for you. So when you wake up in the morning, you can watch them and send them to your friends and colleagues as well. So a couple of items here with Spreecast. If this is your first time in a Spreecast session, we can use the chat window over here on the right-hand side. This is often where we network with one another. Feel free to introduce yourself and where you're from. We love to hear where people are watching us. And also, if you have any questions for our speaker, that's where you should put those. You have to be logged into Spreecast in order to take advantage of that chat window, however. So if you're just a visitor, you won't be able to chat with us, but you can watch the session, so welcome. And secondly, we have a PowerPoint slide that's going to come on air. It's going to come up in its own box, so you can drag and drop that PowerPoint anywhere on the screen you'd like. That's not going to get in the way of you watching the speaker or talking in the chat session. So put it wherever you'd like. And then also you need to follow along. So our speaker will let you know what slide number she's on, so that way you can follow along with her through her slide deck. And I think that's about it. So I'm going to go ahead and introduce Ambs Kesavan. She's with Xilinx, and she is doing a talk on agility and cloud computing. So with that, I'm going to go ahead and put her slide deck up. So as I mentioned, just drag it and drop it anywhere where it's useful. And then go ahead, Ambs. Looking forward to your talk.
Thanks for the introduction, Diana. Hello, everyone. Thanks for joining the session. I work in the software engineering division at Xilinx. Xilinx is a leader in the FPGA industry, and it's a great company to work for. Today, I'm going to talk about agility and cloud computing. There's a major transformation going on in the IT industry. Cloud is a main driver for this transformation. And it has made it very easy for developing and deploying enterprise scale applications. So it's exciting time for developers, operations, and infrastructure teams to be part of this transformation. I am on slide 2. So here's the agenda for today. I'll start with the evolution of IT infrastructure. I'll then give an introduction to cloud computing, various cloud services and deployment models. I'll touch on a couple of cloud providers. I'll then talk about availability and security in the cloud. And finally, I'll wrap it up with the emerging technologies that are going to deliver further efficiencies. Moving to slide 3. As you all know, IT infrastructure has been evolving over the years. In the early days, data centers had application-based silos. So each app had its own server, network, and storage. So there was one-to-one relationship between physical server, operating system, and the applications running on it. So for example, if you had 6 applications, there were 6 separate infrastructure components. So this worked out great in terms of isolation and performance. However, the utilization was very poor, even as low as 15% in some cases. So this obviously resulted in higher costs. Moving to slide 4. The next evolution was consolidation of applications on a single machine. In this example, multiple applications are running on the same physical server. So this improved utilization problem that I talked about to a certain extent. However, the isolation advantage was lost. Also, it was not easy to rebalance applications across servers. So for example, let's assume that you have 6 applications with 3 applications running on first server and 3 applications running on second server. And let's say the first server was very busy and second server was idle. So rebalancing applications between the 2 machines was not easy at all. Now I am on slide 5. So next technology evolution was virtualization. So here you are taking a physical machine and then carving this into multiple virtual machines. Each virtual machine is running its own operating system. In this picture, for example, first operating system could be running Linux and the second one could be Windows. So virtualization is helping with server consolidation, and more companies are moving towards virtualization. According to the most recent IDC report, there are close to 30 million virtual machines deployed worldwide. There are some challenges with virtualization. First problem is virtual machine sprawl. So there could be tens of virtual machines on each physical server, and hundreds, even thousands of virtual machines in each data center. So you need an automated virtual machine life cycle that's very super critical. And managing all these virtual machines manually is very expensive and error prone. There's also another problem. There is virtualization tax, and this affects the performance of applications. This is due to the extra hypervisor layer in the network and I/O path that impacts the overall performance of the applications. Moving to slide 6. So in the last 2 years or so, lightweight containers are picking up momentum. So here you're sharing the operating system and you're creating what are called containers, which are application runtime environments. So it provides the required isolation, very similar to virtualization, but with a minimal overhead. So for example, Linux has a container technology called LXC, and this offers namespace isolation between containers. So there is namespace isolation for process trees, network, mounted file systems, and so on. So it's providing this resource application for applications without requiring a full-fledged virtual machine. So if you are running a web server on port 80 in container 1, you can use same port 80 on another container. So this is isolation of port namespace, for example. So Docker is a technology that is built on top of containers, and it includes framework for packaging and deploying applications. So this is gaining a lot of momentum in the last couple of years. Moving to slide 7. So we have seen evolution of technologies from application-based silos to virtualization to lightweight containers. Utilization and consolidation, it has improved over the years with these technologies. But let's look at what's happening in the data centers. So data centers typically have fixed capacity that's highlighted in the red line in these graphs. And you see 3 different scenarios. The top left chart highlights a scenario where capacity is built to take care of your peak demand. So because of that, there are unused resources during non-peak hours, and that results in waste. This is basically over-provisioning of resources. The top right chart highlights a scenario where there are predictable peaks, and the bottom chart highlights a scenario where there are variable peaks. In both these cases, capacity is built for average demand, as is shown in the red line, and this results in 2 problems. So when demand is more than the available capacity, there is poor service, that is shown in the shaded area, and that represents lost revenue opportunity. On the other hand, when demand is less than the capacity, IT resources are wasted because of over provisioning. So how do we solve this problem? That leads me to slide number 8. So what data centers really need is a solution that offers automated elasticity and scalability. What do I mean by that? So let's look at this chart for a moment. First, look at the black dotted line. So that's the predicted demand for infrastructure capacity. And the red line represents the actual demand. So as you can see, sometimes it is below the predicted demand, and there are times when the red line is above the predicted demand. So basically, prediction is wrong in both cases, and that has financial consequences. So what happens in the traditional model? Companies usually follow two approaches for procuring infrastructure: scale up or scale out. So in this picture, the blue dotted line, that represents a scale up approach. So here you buy few large servers incurring very high cost, and then you increase capacity periodically to keep up with the demand. And the green dotted line represents scale out approach. So instead of buying huge servers, you are buying more commodity servers for a lower price, but you are adding capacity more frequently to keep up with the demand. So for both scale up and scale out approach, you are either ending up in over provisioning scenario resulting in wasting resources, or under provisioning scenario losing customers with poor service. So what you really need is the dark green line. Here the actual capacity is closely following the demand line. So this represents the ability to scale up or scale down based on the actual demand at a very much finer granularity. So how do you achieve this? You need two key capabilities. First one is virtualization, and the second is the accompanying automation technology to be able to add capacity or subtract capacity based on demand. That's what cloud computing is all about. Moving to slide 9. So we looked at the evolution of IT infrastructure. So I want to give an overview of cloud computing. I'm moving to slide 10. So let me first start with the definition. I got this definition from Berkeley RAD Lab, that is Reliable Adaptive Distributed Systems Lab from UC Berkeley. So there are essentially three elements to cloud computing. First one is there's an illusion of computing resources, infinite computing resources available on demand. This includes compute, storage, networking, load balancer, and so on. The second element is there is no upfront cost commitment. You can really start small and add capacity as business grows. This is what gives us the automated elasticity without upfront capital expense. And the third element is you pay for what you use. Pricing policies are very transparent, and this essentially is usage-based pricing. You get charged for what you use. Moving to slide 11. There are three different service models when it comes to cloud computing. First one is infrastructure as a service. So as the name suggests, this deals with infrastructure. Compute, storage, networking, and load balancers are part of this. Here, cloud provider sets up the infrastructure, and it's the responsibility of the cloud user to set up the platform and applications. The second type of service model is platform as a service. And this goes one step above infrastructure as a service in the sense that it takes care of operating system, middleware, and database in addition to infrastructure. So for example, if you're a Java EE developer, you have all the middleware needed to develop and run your Java EE application. In the infrastructure as a service example, cloud user is responsible for installing and setting up the Java EE middleware, whereas platform as a service takes care of this for you. The third type of service model is software as a service. Here the cloud provider takes care of infrastructure, platform, and the application. So application could be enterprise resource planning like ERP or human capital management, HCM or CRM, or a variety of other applications. I'll move to slide 2 where you can look at this in a slightly different way. Here, the blue boxes represent what the cloud service provider manages, and the orange boxes represent what the cloud user manages. So there are two aspects to look at. One is control and other one is structure. So for infrastructure as a service, cloud users have more control. They have a choice on what to run on the top 5 boxes in the stack here. This is like buying the building blocks and assembling the product yourself. It's a do-it-yourself model. On the other hand, if you move to software as a service, cloud users have very little control. Cloud service providers take care of providing the whole stack. So because of this, there's a lot more structure in this model compared to infrastructure as a service. So think of this like buying the finished products. You have room for some minor customization, but for the most part, the structure is essentially set. And platform as a service is in the middle between these two. So you pick either infrastructure as a service, platform as a service, or software as a service, depending on the business needs and also the IT budget. I am on slide 13 now. So in terms of deployment, there are 3 models available. You could deploy any of the services on premise, which is in the enterprise data center, and that's the private cloud. Or you could deploy these services in the public cloud, or a combination of public and private cloud, which is the hybrid cloud. So you could think of this like a 2-dimensional matrix with cloud service models on one axis and cloud deployment model on the other axis. So infrastructure as a service could be deployed internally as a private cloud or externally in the public cloud or hybrid cloud. There's a general perception that cloud means public cloud or public deployment. It's not the case at all. You can set up a cloud infrastructure in your data center, and that's basically private cloud. Or you can get best of both worlds by having parts of your infrastructure in the public cloud and part in private cloud, and that's what hybrid cloud is. Moving on to slide 14. So I've covered various service options and deployment models. So let's go through what the key customer benefits are. There are 3 key customer benefits. First one is IT and business agility. Second one is lower cost. And the third benefit is integrated management. So I'll talk about each one of these in detail. I am on slide 15. This is about IT agility. So I touched on IT agility in the first few slides. So businesses typically have fixed capacity, but what is needed is elastic capacity. We talked about several usage patterns: predictable peak, variable peak, on and off type of usage, and fast growth. In this chart here, the blue line is the actual demand and red line is the automated elastic capacity that cloud software is providing to scale up or scale down based on the demand. That's the IT agility. Moving to slide 16, let me talk about business agility. So in the traditional IT model, infrastructure procurement and deployment take a very long time. Because of this, there is a long cycle time between product concept and release to production. However, with the cloud model, access to resources is much faster and businesses can actually shorten the cycle time from development to test to production. Companies can experiment faster without huge upfront investment and pivot if needed. So this helps businesses respond quickly to changing business needs. Essentially, IT agility and business agility combined will help drive superior business performance. Moving to slide 17. So the second key benefit cloud computing offers is lowering cost. So I talked about no upfront capital investment. So infrastructure costs will essentially be operational expense instead of capital expense. And even within the operational expense, total cost is reduced further because cloud providers have economies of scale that individual companies cannot realize. And the other driver for lower cost is the automation software that makes all this magic happen. So there is essentially no reason to guess capacity and unnecessarily waste IT resources or lose customers because of poor service. And finally, you're paying as you go. It's usage-based pricing. You're only paying for what you use. Slide 18. So the third key customer benefit I want to talk about is integrated management. There's a single pane of glass for management and self-service provisioning capability. And cloud vendors provide command line interfaces, REST-based API, and browser-based user interfaces for administration, monitoring, and management with minimal human touch. So this reduces the burden on the users from undifferentiated heavy lifting, using manual processes for installation, configuration, and constant upkeep. So they can devote all the time and energy on the core business needs. And one other benefit I want to point out is all these leading cloud service providers, they have data centers all over the world. So if your company is geographically distributed or expanding into new markets, you can use cloud technology to provision services globally and be up and running literally in minutes. So these are some key benefits in the management area. Moving to slide 19. So I talked about 3 customer benefits: IT and business agility, lowering cost, and improved management. Next, I want to talk about cloud adoption. I'm on slide 20 now. So how big is the cloud market? So I'll start with the IDC report. As you can see in this chart, as of 2014, businesses spent around 56 billion on public cloud services. This includes all 3 offerings: infrastructure as a service, platform as a service, and software as a service. And as you can see, software as a service is a bigger chunk of the market. And it's forecasted to more than double in 4 years. And that's a CAGR, compound annual growth rate, of 23%. And that's very impressive. Moving to slide 21. So next couple of slides are about analyst reports on cloud. The first one is from Gartner. They evaluate companies on two dimensions, completeness of vision and the ability to execute. And this chart is for infrastructure as a service. So as you can see in this chart, AWS and Microsoft are in the magic quadrant in the top right. Both these companies are strong on vision and their ability to execute. Moving to slide 22, this is a chart from Forrester. And Forrester is also another reputed analyst firm. And they have what is called Forrester Wave. And they evaluate vendors on two dimensions again. One is strategy and second is the current product offering. And this chart is for all enterprise public cloud platforms. And again, as you can see, Amazon and Microsoft are the leaders in the top right. They are strong in strategy as well as current product offering, according to Forrester. Slide 23. So this slide is a result of a survey done by RightScale. And RightScale is a cloud management company. So for the question on cloud adoption, 93% of the respondents came back and said they are using cloud. And customers are adopting all three delivery models. 88% of the customers are using public cloud. 63% of the customers are using private cloud. And the intersection is about 58%. They are using both private and public cloud. On the right hand side, you see companies of all sizes are using the cloud, big enterprises as well as small businesses. So the second column has large enterprises that have more than 1,000 employees. And the third column is for small to medium sized businesses with less than 1,000 employees. And the top chart is for public cloud usage and the bottom chart is for private cloud usage. So essentially, cloud adoption is very broad across all business sizes, and also they are using all three delivery models, private, public and hybrid. Moving to slide 24. Next, I want to talk about a couple of service providers. I'm on slide 25 now. So first, let me talk about Amazon Web Services. Amazon is a pioneer in the cloud market. AWS, they have a very rich portfolio of broad and deep infrastructure services, and they also have a very rich platform services. On the infrastructure side, they have services for compute, storage, content delivery, databases and networking, and that's the top row on the slide. And platform services are in the bottom row. They have support for analytics, application services, deployment and management and mobility. So for example, on the compute, Amazon has what's called EC2 service. It's the elastic cloud computing. And this supports both virtual machines as well as container technologies. You can deploy virtual machines and run various flavors of operating systems like Linux and Windows. On the storage, they have elastic block storage called EBS. They have S3, that is for object storage, and they have archive storage called Glacier. So applications can choose any of these three storage options depending on their needs. On the database side, they have relational database RDS, which supports Oracle, MySQL, Postgres, and so on. And for NoSQL, they have what's called a DynamoDB service. So if you come to the bottom row, under deployment and management category, I'll highlight a couple of things here. First one is cloud formation. And this is used for automated provisioning of infrastructure using templating techniques. CloudWatch is another service that is used for monitoring, for example, monitoring compute, storage, network, and applications. You can actually set up thresholds and alerts to be notified when there are exceptional conditions. In fact, Amazon's auto scaling capability leverages CloudWatch technology. So if utilization metrics crosses a certain threshold, you can set up rules to automatically add extra capacity. Similarly, you can scale down when the utilization level drops below a certain threshold. It's a very powerful feature for automated scaling. Moving to slide 26, let me talk about a case study. You might have heard about Airbnb, and this is an online community marketplace that connects people looking to rent their homes with people who are looking for accommodations. So approximately 200,000 people are hosted on any given night. And the need for infrastructure is constantly growing for Airbnb. Currently, they have over 50 terabytes of storage space for user-generated content like pictures, locations, reviews, and so on. And the chart below highlights the growth they had in terms of guests in the last 1 year. As you can see in this chart, they grew by 10 million guests in 1 year. So their business is growing very rapidly, and this puts tremendous pressure on the infrastructure needs. So what did they do about it? Slide 27. So they chose AWS for running the platform. They use a number of services from AWS. For compute, they use Elastic Cloud Computing. For storage, they use Object Storage, S3. And they use both relational database as well as NoSQL database based on DynamoDB. And they use several other AWS services. So how does this model help Airbnb? So I actually talked about their growth in the previous slide. So let's assume that they went with the traditional on-premise infrastructure model. As you can imagine, there's a lot of variability in the demand pattern. So they have to constantly guess capacity. And because of this, they have to incur either over-provisioning or under-provisioning cost. And they also need to have a large operations team with compute, storage, and networking specialists to deal with the whole stack. By going with AWS, they took these costs away and got the IT and business agility. They are operating with a very small operations team, even though they have 1,300 EC2 instances and more than 50 terabytes of storage. Moving to slide 28. So this slide has a large list of enterprises running on AWS, spanning multiple industry verticals. There are typically 3 types of usage scenarios. First type is new workloads that are cloud native. So these are applications developed for the first time using cloud capabilities. They are typically in analytics or mobile or social area. There are second class of customers. They are supplementing their existing workloads to deal with the peak demand. And the third type of customers where the entire IT is in the cloud. Netflix is an example here. They are running entirely on AWS. Amazon also has what's called the AWS Marketplace. This enables buying and selling of software that runs on AWS cloud. So ISVs and developers, they can build AWS cloud applications and sell them on the marketplace. That will actually broaden their reach. This is an interesting opportunity for both buyers and sellers of software. It's like an app store model where there is revenue sharing business model, and Amazon actually shares part of the revenue with software developers. Moving to slide 29. So that wraps up my discussion on AWS. Now I want to talk about OpenStack. I'm on slide 30 now. So unlike AWS, which is a proprietary cloud technology, OpenStack is a collection of open source software components. There is Openstack Foundation, which has around 475 members. Some of the big name companies are actively contributing. This includes IBM, Intel, Red Hat, Cisco, and many others. And a lot of these companies contribute in two ways. One is on the technical front, contributing to design and implementation. And the second area is they are contributing financial resources. Also, there are several vendors that are selling cloud products and services based on OpenStack technology. And just like AWS, OpenStack also have components for storage, networking, monitoring, and identity management. So if you look at this picture, Horizon is a management dashboard. Nova is a service for compute. And for storage, they have Glance, Swift, and Cinder. Cinder is a block storage, and Swift is object storage, and Glance is used for storing images. I'll move to slide 31 to talk about a case study. A very high-profile customer for OpenStack is PayPal. As you know, PayPal is a global company with a very massive scale. PayPal has over 150 million users worldwide, and they process over $425,000 in payment volume every minute. So as you can imagine, the infrastructure demand to support operations at this scale is very high. They need agility, scale, and easy to use self-service tools for application management. So the picture shows what they wanted to build. They have several applications at the top. They have payment application, wallet application, mobile and risk application. And they wanted a unified platform as a service layer, and then infrastructure as a service layer right below that. And they also have several environments. They have a development environment, QA environment, pre-production and production environment. And they also needed monitoring service for all these environments. So what did they do to solve this problem? I'm moving to slide 32. So PayPal chose OpenStack, private cloud deployment. So the picture here shows the high-level architecture. So they are using a number of components from OpenStack in their solution. So for compute, they use Nova. For storage, they are using both Cinder block storage and the Swift object storage. And Horizon is used for dashboard. And that's like a browser-based user interface for providing management console. So in this picture, you see operations portal at the top, that's for cloud administrators. And then you see a PD portal, and that's for product development engineers. Then they use Heat for orchestrating various services. And they use a service from OpenStack called Celometer for metering and getting the utilization metrics. So in terms of benefits, this provided the required developer agility and self-service provisioning capabilities on the operations side. And because it's all open source, they got the flexibility to customize the code for their environment. So in this picture, there are a couple of green boxes, and they are all PayPal specific code. They implemented their own load balancer as a service, firewall as a service, and DNS as a service, for example. In fact, they were talking about contributing all of this code back to the community so that others can also benefit from these services. That's the beauty of open source software. And recently, I also came across another article that Walmart was using the OpenStack in production for their global e-commerce. They are using OpenStack compute layer Nova with over 100,000 cores. And they are actually looking to expand Cinder block storage, Swift object storage, and Neutron technology for networking. It's very impressive. Moving to slide 33. So I talked about AWS and OpenStack. There are many other cloud service providers. Microsoft has Azure, and it's a platform as a service offering. And here you can run both .NET and Linux applications. Red Hat has both infrastructure as a service and platform as a service offering. In addition, Red Hat also has an OpenStack based solution. IBM has SoftLayer, which is infrastructure as a service, and Bluemix, which is platform as a service. VMware, for example, has vCloud Suite, which is a private cloud solution, and then vCloud Air, which is a hybrid cloud solution. So that wraps up my discussion on various cloud providers and also a couple of case studies. Next topic I would like to cover is availability and security. I am on slide 35 now. You know, cloud is a much talked about topic in the IT industry if it made it to Dilbert. This is a pretty good joke on cloud availability, and I want to prove Dilbert wrong in the next couple of slides. There's actually a lot of fear around availability and how secure the information is if it is deployed to cloud. And that's one of the barriers for adopting cloud. First of all, cloud does not necessarily mean public cloud. There is private cloud also. And availability best practices in private cloud are no different from what you have in the traditional deployments. We just talked about PayPal. They transitioned from the traditional deployment to a private cloud model using OpenStack. And they did not compromise on availability or security by moving this transition to private cloud. However, for public cloud deployments, there are additional availability and security issues to consider. So let's see how the public cloud vendors handle this. So I'm going to slide number 36. So let me talk about the first let me talk about the availability. So AWS, Amazon, for example, has a notion of regions and availability zones. So you can think of availability zone as a data center. So each region has multiple availability zones, and there are multiple regions all over the world. So Amazon has 11 regions and 28 availability zones. And Microsoft Azure has a very similar availability model with data centers all over the world. So this geographical distribution of data centers help with both high availability and disaster recovery. So I want to expand on this a little bit more. So let's move to slide 37. So let's say you're running a mission critical application that has stringent availability requirements. So you typically don't run it in just one data center. You have to build enough redundancies to survive multiple levels of failure scenarios. Failure could be application level failure, or it could be a system failure. It could be a data center failure, or a disaster that could take the whole region out. So in your traditional on-premise deployment, you have to set something like this on your own. You're doing all the heavy lifting yourself. And this will be very expensive, both from hardware perspective as well as labor cost. And you have to hire high availability specialists to deploy this configuration. And you can achieve the same level of availability in the public cloud deployment also. So here, the top picture highlights a scenario where application is spanning two availability zones, West 1 and West 2. So let's say West 1 goes down. services are failed over to West 2 and end users are not impacted at all. So applications typically do synchronous replications of data across availability zones. So the second example is where applications could be spanning multiple regions. For example, one region could be in US, while the second region could be in Europe. Here the applications typically do asynchronous replication of data across regions, and they can survive the entire region failure. So cloud providers can not only provide availability and disaster recovery, I would argue that they can provide it at a much cheaper cost. They get the economies of scale because of the global operations across a large customer base, and they pass some of the savings back to the customers. To replicate something similar in the traditional data center, it's going to be very expensive, and you have to hire high availability specialists, like I mentioned, and build redundancy at every layer in the stack. That's about availability. The next topic I want to cover is security. I'm on slide 38 now. And security spans a lot of areas. There's compliance and certification aspects. There are several compliance and certification standards depending on which industry you're operating in. There is HIPAA for healthcare, PCI DSS for payment industry. There is DoD and ITAR related to Department of Defense and Military. FIPS and FedRAMP related to federal compliance programs. So several cloud companies, they have compliance and certification programs for all of these. They have very good rigorous programs getting certifications to adhere to highest security standards. And the other area in the security context is availability and business continuity. And we just talked about both availability and disaster recovery topic. The third area is identity and access management, where users have role-based access control that specifies who has read access, who has write access, and all these accesses are logged for audit purposes. And they also have the sequence of activities in a chronological order. The next topic is data security, and this is handled by data encryption both during transit as well as at rest. And encryption keys are private and are accessible only by the customers. And the last topic is virtual private cloud, VPC. So here actually you can have control over which cloud resources should be public facing and which should not be public facing. And customer can access resources in the cloud over IPsec based VPN. So secure infrastructure resources are only available from the company intranet. So if you have web server and database server, web servers will be public facing and your database servers need not be public facing. So there is extra level of security here. So this wraps up what I wanted to say about security. The last topic I want to talk about is emerging technologies. I am on slide 40. So you might have heard about software-defined infrastructure or software-defined data center. It has three components: software-defined compute, that's virtualization that we talked about. There is software-defined networking and software-defined storage. These three things together provide software-defined data center. So I'll briefly touch on software-defined storage. So the problem is exponential growth in data. Traditional storage management practices are very inefficient to deal with this exponential growth. So solution is software-defined storage. At a very high level, applications specify the storage capacity and performance requirements in terms of throughput and latency. So for example, this top row in this picture, there are three applications here. So app 1 is basically saying I need 7,000 IO operations per second. So the orchestration layer that you see in this picture takes this input and automatically figures out which storage device should be associated with this application. And that's based on the knowledge it has about the storage infrastructure attributes. So in this example, app 1 is serviced by storage subsystem 1, the leftmost yellow box. So the intelligence to pick the best storage that the application needs, that sits in the orchestration software layer and also in the software defined storage controller layer. Similarly, app 2 has a throughput requirement of 2 Mbps. It's served by storage box in the bottom right. So software defined storage is the glue that sits between application and the storage. And this is going to drive further efficiencies across all storage components in the data center. So that's software defined storage in a nutshell. That brings me to the summary slide. I am on slide 42 now. So cloud computing is going mainstream. There are flexible service models. There is infrastructure as a service, platform as a service, and software as a service. And these can be deployed either on-premise in private cloud or public or hybrid cloud. And cloud technology offers IT and business agility at a much lower cost. And it's a strategic differentiator for the businesses. Businesses can focus on their core products and grow revenue and profits. So as I mentioned at the beginning, cloud computing is exciting technology. It opens up a lot of opportunities for developers, operations, and infrastructure teams. And from business perspective, it gives the unique opportunity to innovate faster and also build a sustainable competitive advantage. That wraps up my presentation, and I'm happy to answer any questions. Diana, are there any questions?
I guess not. That's amazing. I'm really fascinated. Can you tell me, about your role at Xilinx and how exactly, you gave a lot of great case studies. So are you working with these organizations in how they're developing their storage, or what are you doing exactly?
Xilinx, we use a number of technologies based on the application and also the business need. So we have both physical infrastructure as well as virtual deployments that I talked about. Also, we have business applications that are running in the cloud wherever it makes sense. And we are constantly evaluating.
Well, the Airbnb one is just mind blowing. I mean, scaling up like that in 1 year, 10 million, it's just unbelievable. Yes. And it's amazing. Yeah.
Airbnb, PayPal is also another great example because they decided to go open.
It's fascinating. I mean, it's really Walmart is a game changer where, for little money now, you can start a company on AWS and just go crazy. It's just fascinating stuff.
Yes. Yes. Yeah, one thing I didn't mention is AWS actually has a free service for 1 year for people who are just trying to start. They don't even need to pay money for 1 year for, again, a small subset of people.
So we had some feedback here. That's great. Thank you very much for your feedback. Appreciate that. All right. Well, if there's no more questions, I guess we're going to wrap up. Great talk. Thank you so much. This URL will be available for watching the recording. We've been getting hundreds of people watching these recordings, so feel free to share this with your friends and your colleagues who might be interested in this space. I know I'm going to be sending this to my husband, who has been working with AWS recently, and I'm sure this is going to be a fascinating conversation for him. So thank you very much for everything, and I hope that you'll stay tonight and watch some of the other sessions or watch the recordings in the morning. Thank you so much. Appreciate it.
Thanks for the opportunity.
Bye, everybody.
Anna. Really appreciate that.